We are going to be dividing polynomials for the next 2 days, but today we're doing parts A and B. Tomorrow we'll do parts C, D, and E. Essential understanding for polynomials. Polynomials can be divided using steps that are very similar to the long division steps that are used to divide whole numbers, okay? Again, that's why your Do Now had you watch that video recalling how to divide numbers in general, okay? Division terminology. So when we are dividing, these are the words that are being utilized. So your divisor is how many groups you're trying to make, or how many in each group you want. Your dividend is what you're starting with, how much you have in total. Your quotient is your result, and your remainder is your what's left, right? All those sound familiar? Okay. When you have a division problem, it could be written in several ways. So if I have 277, so 277 divided by 12 equals 23 with a remainder of 1. Do you remember that? Like seeing that written, that famous R? Yes, vaguely. Hopefully that makes sense. Okay. Division can also be written as a fraction. 277 divided by 12. Okay. When it's written as a fraction, typically your answer is written as a fraction. So you have 23, and instead of remainder 1, it's 1/12. Okay. And so here, when it's written as a fraction, what my teacher told us is that your dividend and your divisor, your dividend is the cowboy, your divisor is the horse. And at night, the dividend goes inside the house and the horse stays outside, which is your divisor. Okay. So you learned all of this in elementary, right? 3rd, 4th, 5th grade material here. Now, translating into Algebra 2. In Algebra 2, we're now dividing polynomials, okay? So we're saying that we have 2x squared plus 7x plus 7 divided by x plus 2. And in this case, it equals, the quotient is 2x plus 3, remainder 1. Okay, the only difference between the arithmetic long division and the polynomial long division is variables, but the process is still the same. Can you see the similarity in the process? Yes, I hope so. All right, so when dividing polynomials, you can divide p of x by polynomial d of x to get a polynomial quotient q of x. So it's just using more variables at this point to describe what's happening. And the result is going to be the polynomial equals your divisor times your quotient plus your remainder. That's how you come up with the polynomial. It's your divisor times your quotient plus your remainder. Okay. If your remainder equals 0, then that lets us know that our divisor and our quotient are factors of p of x. So if our remainder equals 0, then our divisor and our quotient are factors of the polynomial. So using polynomial long division, here are the steps that we're going to follow. We make sure polynomials are in standard form, okay? Standard form means we're in decreasing power order. So we would have ax to the 4 plus bx to the 3rd plus cx squared plus dx plus e. We're in decreasing order, okay, of power. The other thing is fill in any missing terms with 0 placeholders. So if I was missing my cubic term, I would put 0x cubed. If I was missing my quadratic term, I would put 0x squared, okay? So any missing term, you fill in with 0 as a placeholder. And then we begin the process. So we divide the first term, because if you remember, the process for log division is divide, multiply, subtract. Oh, I forgot bring down. Oh no, I forgot a step. Bring down. Oh, I can't believe it. I just forgot to write it there. You bring down and then repeat the process until the degree of the remainder is less than the degree of the divisor. Okay? So same thing here. When you divide, it's the first term of the dividend by the first term of the divisor. and you put that result on the quotient line. Then we're going to multiply the divisor by the answer. And we're going to put that below the product, below the dividend. This is an excess. Oh my gosh. Put the product below the dividend. I didn't mean to write the below twice. Put the product below the dividend. And then we're going to subtract to create a new polynomial. This means you're changing the signs of each term. And then bring down, repeat the process until the degree of the remainder is less than the degree of the divisor. Now, sounds like a lot of words, but the process itself is fairly simple. So example 1, we're going to use polynomial long division to divide 4x cubed plus 3x squared minus 20x minus 46 by x squared minus 5. Okay, so the first thing we're going to make sure is that step 1 is that all polynomials are in standard form. So our quotient, not our quotient, our dividend, this guy right here, this is our dividend. It's in polynomial, a standard form, right? So it's good to go. And there's no terms missing. Our divisor, this right here is our divisor. Our divisor is in order, but there's a term missing. Do we see that there's a term missing? So our divisor, we're going to rewrite it as x squared plus 0x minus 5. So I had to put in that placeholder because there was a term missing. I was missing my linear term. And then we're going to begin the process of dividing. So we have x squared plus 0x minus 5 divided by 4x cubed plus 3x squared minus 20x minus 46. Step 2 says we're dividing our first term, the first term of our divisor, into the first term of our quotient. So we're dividing x squared into 4x cubed. So we have 4x cubed divided by x squared. That equals 4x. Do we all agree with that? So we get 4x, and then we place that result on our quotient bar. So we have 4x. Step 3 says we're going to take that value and multiply our divisor by that value. So we're going to take 4x, I didn't mean to put 3 over there, and we're going to times it by our divisor. So we have x squared plus 0x minus 5 times 4x. We're going to distribute that, and that gives us 4x cubed plus 0x squared minus 20x. So we have 4x cubed plus 0x squared minus 20x. So we divide, we multiply, and then step 4 says we subtract. So we divide, we multiply, we subtract. When you're subtracting, that means you're changing the signs of all the terms. Subtract, this goes away. 3x squared minus 0x squared is 3x squared. Negative 20x plus 20x is 0x. And then step 5 is to bring down. So we're going to bring down, and we repeat if the degree of our remainder is not less than the degree of our divisor. So these are not less than, they're still equal to. So we repeat the steps all over again. So now I'm doing x squared divided by 3x squared. So we have 3x squared divided by x squared. What does that equal? or 3? It equals 3. So we have a positive 3 added to our quotient. So again, we divide, multiply. We're going to take the 3 and multiply by our divisor. We're at the multiplying again. So we have 3 times x squared plus 0x minus 5. I distribute the 3. That gives me 3x squared plus 0x minus 15. So my product is 3x squared plus 0x minus 15. So I multiply. Now I'm going to subtract. Again, subtraction means you're changing the signs. Subtract, subtract, subtract. Cancels out, cancels out. And I'm left with negative 46 plus 15 is going to give me negative 11. That's not negative 11, negative 31. I don't know where that came from. I was just making sure you were paying attention. It's a negative 31. Yeah, I was. All right. So at this point, you bring down, well, there's nothing to bring down, and you don't repeat because your remainder, the degree of the remainder is less than the degree of the divisor. So your answer is, the remainder is negative 31. So your quotient is 4x plus 3. Your remainder is negative 31. Now, when you get into pre-cal, you will write this differently. When you're in pre-cal, you will write this as 4x plus 3 plus, not plus, minus 31 over x squared minus 5. That will be your grown-up answer. But for us, can you identify the quotient? Can you identify the remainder? All right, how we feel? Remember, same things. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. The only difference here is that you have variables and you have excess, you have terms instead of place values. It just looks like a lot more. Okay. All right, let's try it again. So this time we have, this time we have 3x cubed minus 8x squared minus 21x plus 56. So this is our dividend. And here's our divisor. Step 1 says make sure your dividend and divisor are in polynomial standard form. And if there are any missing terms, use 0 as a placeholder. Well, again, our divisor is missing a term. So we have x squared plus 0x minus 7 is what our divisor will be. So we're going to divide this into 3x cubed minus 8x squared minus 21x plus 56. Okay, we're going to start with our D, our divide. So we're going to divide the first term of the divisor into the first term of the dividend. So we have 3x cubed divided by x squared. What does that leave me with? 3x. So that goes on my quotient bar. Step 3 is to multiply. So I'm going to multiply that quotient by my divisor, times my divisor. So we have 3x times x squared plus 0x minus 7. Distribute. And we get 3x cubed plus 0x squared minus 21x. So we have 3x cubed plus 0x squared minus 21x. Step 4 is to subtract. Subtracting means that I'm changing the sign of each term. When I subtract, it eliminates my cubic term. When I subtract, that leaves me with negative 8x squared plus 0x. Step 5 is to bring down and repeat. So I'm going to bring down plus 56. And we would repeat because the degree of our remainder is not less than the degree of our divisor. So repeat it again. So we have x squared and we have negative 8x squared. We're going to go through the same steps again. So step 2, we divide. So we have negative 8x squared divided by x squared. What does that give me? Negative 8. So negative 8 goes on our quotient line. Step 3 tells me to multiply. So I'm going to multiply negative 8 times x squared plus 0x minus 7. That gives me negative 8x squared plus 0x plus 56. So we have negative 8x squared plus 0x plus 56. Step 4 tells me to subtract. Subtracting means I'm changing the signs. And they all end up. So for this one, I do not have a remainder. Do we see that? So there's no remainder. So no remainder. So my quotient is 3x minus 8. What that means is that x squared minus 7 and 3x minus 8 are factors of the polynomial. All right. Again, it's a lot of writing, but this right here, this is your thought process. So if you can do this mentally, cool. This is what you're thinking. This is your thought process. All right. All right, so you try. So you have 4x to the 4th plus 14x squared plus 12. So here's your quotient. Not your quotient, your dividend. I want to keep saying quotient. I have no clue why this morning. Here's your dividend. Here's your divisor. And when you look at your dividend divisor, you can see that there are missing terms. And as you're doing this, you may realize that you didn't have to actually necessarily add those terms because of what type of dividend it is. But here we go. So we have 4x to the 4th plus 0x cubed plus 14x squared plus 0x plus 12. So I was missing terms in each one. Fill those terms in. Step 2 is where I begin everything. So I'm going to start with my dividing. So I divide the first term of each dividend divisor. So 4x to the 4th divided by 4x squared is just x squared. And I'm going to multiply x squared times each one of these terms. So x squared times 4x squared is 4x to the 4th. X squared times 0x is 0x to the 3rd. X squared times 2 is 2x squared. So step 3 is completed. I multiply. Step 4 is to subtract. So subtracting means I'm changing their signs. 14x squared minus 2x squared is 12x squared. The degree of my remainder and the degree of my divisor are equal, so I can still repeat. So I'm going to bring down. And repeat. So I have 4x squared and 12x squared. 12x squared divided by 4x squared. First thing I got to do is 3. And then I multiply. 3 times 4x squared is 12x squared. 3 times 0x is 0x. 3 times 2 is 6. Multiplication done. Then I subtract. So subtraction means I change the signs. My quadratic term is gone. My linear term is gone. And I'm left with my constant of 6. I don't need to bring down a repeat because the degree of my remainder is smaller than the degree of my divisor. So I'm done, and it has a remainder of 6. The reason why you wouldn't have to necessarily in this situation have to put the placeholders is because remember we talked about yesterday or the day before that this is a quartic trinomial and its factors are going to be a quadratic and a constant. And so, but it's good to practice it because it doesn't always work out that way. All right, but that's the division.